Okay, so I think we can start. Now please have a seat. So now we are going to talk about the concept of data lake. Okay, so if I ask, have you guys heard about data lake? How many of you really heard about the concept of data lake? It's being coined a lot these days, and it's like kind of separation from traditional data warehouse and the thinking towards how the HDFS is. So far, like we spent 1 hour before about HDFS and MapReduce. So now you have the idea that, okay, what is HDFS? Hey, Saul. Okay, sorry about that. Yeah. So, yeah, thank you. No worries, dude. No worries. Yeah. So, if you are coming into Hadoop or HDFS or thinking about how data is really stored, the way it is that when you are moving from traditional RDBMS or data warehousing, the concept of data lake really changes how last 20 years you really thought about data is really stored. It's sometimes if companies like healthcare, all those things, they just really, they just go berserk when they think about, oh, data lake is something coming to organization where security is paramount for them. So in this 1 hour session, we will try to understand what that data lake thing is and what's the conceptual information we have about data lakes, you know, how we really build it if we really want to build it, something like that. Okay, and the later half we will look into in same hour that how that data processing is done, you know, and I can technically explain you within the HDFS how the processing is done. So unfortunately we are not talking about from code perspective what kind of code you need, what kind of library you really needed to do it, but conceptually how the processing it really needs to be done if you are processing data within the HDFS layer. So data lake or data graveyards, it's a concept really not very old. It's still new, about 1 or 2 year. Companies like Capgemini or Pivotal, they are really trying to push about this, you know, lot more. They really talk about, and companies Platforma, and now the Teradata, who is like the #1 in data warehousing, as well as, you know, these guys are really trying to give a different spin on what the data lake is. Okay, so that's another way to look into. So like, who's that? Anybody? How many person here play Halo or Halo on Xbox? It's Master Chief. You know, it's like I play Xbox. You know, and then it goes a lot behind it. You know that when I was in Microsoft, and how we really thought about how we really transitioned from traditional RDBMS and how we thought that data lake is really going to help us. So it's like, and that the concept has knowledge built into. So if you are an organization where you really think that, oh, this is something is going to either resonance, or you're really trying to understand that this is what it could be an answer for your enterprise objective, that storage really has a lot of learning. So when we were working and we released Halo 3 2011, we were at any given time 3 million players were playing Halo worldwide, about 1 million in US and 2 million outside US. So 3 million players playing game at any given time, and we would say that about 1 million players are actively playing. Okay, and then all that statistics when the character is moving, you know, from how the labels are changing. So like everybody almost in a room played some kind of games. So you know that player has in the game there is an object which moves, and there is a label or world which really shifts. Okay, in some games it doesn't shift. So there is a lots of data at any given time. And we were using traditional SQL to collect all that data and process it. And there was a lots of data because when you are in world, you are seeing buildings, you are seeing road, you are seeing billboards. And I don't know if you know or not, those billboards are actually showing the ads. And those ads are being paid by some other companies when somebody is being playing. Okay, and those ads are really being pushed based on several analytics, based on user demographic. If a person who is 20 years old playing game, they will try to show the ads related to him, versus if a player is 35 years old playing the game, the ads are different. So there is a lots of analytics really being done during that game. Not only that, because I was in cloud, my job was to really keep the things running well. So my interest was how machines are really working, which machines is really impacting by any reason, and what kind of impact is happening, and what is the probability that this machine might go down very soon. If machine goes down, it's going to impact the players. Okay, how long that players are going to be impacted with that. So we were doing all that thing with traditional SQL server. It was going really very well, but by the time we had this bust when suddenly that we released a new world, there was a new label we released, like if you play a certain amount of time, a new world is open for you. And so and as new world, everybody's really excited to go, and we really see that a lot of activity going on. Everything was really being slowed down. Again, I would say Oracle, SQL, they are amazing tools. They are not going anywhere in near future. They have their presence in enterprise, and they are not going to lose their shine. It's a new market, new way of doing things is what is really bringing Hadoop as a new player. There is a lots of legality because the finance companies, analysts, third-party companies who are bidding on our platform, there were so many things were happening, and everything is happening at really very sub-second level to minute to hour level, depending on how fast, how soon you really need to get all that data. Everything was going well. However, whenever we get this flurry of information, when suddenly everything goes down, because the cluster is designed to process X amount of data in N amount of time, resulting M amount of results. When we were having these kinds of events where suddenly things going up and down, results were still available, but the time to arrive to the conclusion was really very long. And if that time, if it is really long, in certain cases, you might not apply certain features. So you cannot apply the ad when it should be there. You cannot solve a problem when you really see a problem. You solve the problem, it's already 2 hours and the player already left it. In certain area, in certain geolocation, the network is suddenly congested. Now the players are having very low latency. Now they really cannot move to the world properly. Those kind of problems which were not in our control, but we still need to look into. So what we did, so we had worldwide almost about 1,500 servers. Their job was to collect that data, just data collection and aggregation, and they all were writing back to the SQL server. Okay, and that's a traditional, because if you are collecting data from one single machine, or you are collecting data from thousands of machines, you are still creating pretty much same model, which is just distributed and which is just writing to the data. Data was being written on SQL. What we did, rather than, we were still writing at the SQL, but we copied that stream. And now what we did, we just channeled that data to our Hadoop cluster. So we had these 15,000 nodes worldwide, somewhere in Europe, US, India, Singapore, Japan, South America, and their job was to collect that data. And we have in Hadoop ecosystem, there is a application called Apache Flume. And what Apache Flume does, it aggregates the logs. So what you do, you have hundreds and thousands of machines. You put the Flume and flume that data, collect data from thousands of these nodes wherever it's coming out, it's put together in one stream, and it's create one single pipe. Now that data is written into the HDFS. And now you know that HDFS is a distributed file system, which sits on native file system. So if you are running, mostly everybody runs Hadoop on Linux, which is a native operating system, and now Hadoop is also available on Windows. Not everybody uses it, but it's still available over there. So you have native file system, and then you have a Hadoop file system, which is scattered on all these machines. So from Hadoop perspective, is a one single file system. So now this data is coming from tens of thousands of stream, and it becomes a one single pipe, and it's writing on HDFS. It's a one single large terabytes of file size. Logs are there, and if you think about 80% to 90% of the information in the log is redundant. Millions of players playing in same game, they have same object, it's really moving. So almost the moves, if you think about that, the information which is really very important is about 20% of the information is what we really need to process. But 80% is redundant data there. If you are using traditional SQL, you are processing data, because there are so many ways to process the data. In the last 5-8 years, technology changed. Somebody really talked about the Colmar technology. How many of you heard about the Colmar databases? Like column databases, so a few, and then just for references, because if you think about that, if you are searching a table and which has a 3-column, name, age, zip code, and if you are putting this whole information in as a complete row, what's going to happen? If you say, give me the list of everybody who is from zip code X, the request is going to go sequential, and it's going to search every row, all 3 columns, and figure it out the number of articles or number of rows which has a zip code which you have given. What if I take these 3 rows, 3 columns, and I cut in 3 different pieces, and I store each column in 3 separate machines? So now what I'm really trying to do, I'm trying to say, give me the list of this zip code. Now you are, rather than searching 3 columns, you actually became 1 column. So depend on your column size, depend on the data, you actually reduce your search time. Now you got the zip code, now you go back to look up in text, and you really get those rows. And then you can get, so that's why your search will be super fast. When you are searching with hundreds of columns, because if you are looking into the enterprise, the click stream analysis, when you go website, everybody is really being tracked. You go Amazon, you go Google, you go Netflix, your all activity is really recorded. Does anybody know that the click stream data, how many fields are there? That when you go click on any website, you are being recorded by servers. There are 300 fields in that data. And in order to process, so for example, if you go, the way the Google really try to understand experience and try to superimpose ad for you, they have about a second or 5-second time in order to understand you, so that they can really put certain kind of ads against you. It's all done in seconds, sub-second level. Just a really large amount of, so there are really smart ways to do this, do that thing. So what we did, so we collected that data. So now you see here that rather than thinking about all that concept of databases, we collected that data, and we really didn't think about who really needed what kind of information. There was a bidding company, so the company who really understand the bidding. There was a team like us who really want to know what's going wrong within the infrastructure. So we are looking into from infrastructure. There are company, the programmer, they really want to look into which level is really being used, loved by players. Which level they spend more time, so they can really see which level was really garbage that nobody liked it, because nobody really spent in that area. If the puzzles they put it, whether they're really being played by somebody or not. If they played by somebody, how long it took to solve the problem, whether by the time they solve it, 80% of person thought it was so much too waste. So there are lots of analytics going on. So once we dump all that data, now in terms of SQL, we had this SQL guy who really had these, or we had these SQL queries already designed. Once data is done, the data is moved from live database to our EDW platform, where the different kinds of data, so there is a data for analytics, data for logs, data for other teams are available, and these teams are looking into that data and really processing it. For a minor change, they really need to go back to the drawing board and request for a next query. But the thing was that nobody has access to real data. Okay, and then by the time the data was available for these guys, it was a very small piece of data. So what we did now, once we arrived at this, so just for as a proof of concept, we just try to understand the logs. We just created Hadoop where we really filter out everything redundant data. So rather than redundant data which has a log, it's just a counter, like that particular line was written written like that many times, even if it's thousands. Now suddenly from millions of lines which is really being written on minute or 10-minute basis, now we have really very small percent of data. So we clean the data immediately. Okay, once we that, now the data became really small. Now it was really very easy to figure it out where the problems are, where the network latency is lower than average, where the spikes is there, where we really see that at what time users are. So it became really very good. All that thing could have done, and that same thing really, once one team job was done, then other teams was giving access to that data, so they can really look into. But the good thing here is that every team has access to full size of data, not a piece of data. In current analytics world, when we look into business analytics applications, that's where you think there are analytics applications which runs on your machine and do analytics. The problem is that if you think about, if you are running an application on your machine, it's going to use your machine resources to process that data. There is a chance when it's using connectors and connecting to the distributed systems, requesting that machine to process data for you, and then the data is processed, then it has to pull that data back for you. So you are limited with your network pipe now here. So unless you are running natively, when I say natively means you are next to cluster, your application is actually running as a part of cluster, then you are native. Otherwise, so that's why the business analytics and the concept of big data analytics is a really very thin term. We can argue hours about it, that big data analytics is considered when the analytics is done natively on the cluster and used by native processing engine. So if you are doing analytics and you are using MapReduce as your processing engine, then it's really called the big data analytics. So that's what the concept of data lake really, it gives you ability to access full data and write applications where you can really use power of MapReduce to process the data. So here is a traditional data warehouse. I think everybody in the room might know it. So what is happening? So what is a database and why there is an ETL? I think ETL, everybody understand ETL? It's called extract, transform, and load. It's a regular process, and why it is really needed? Because the database, so if you look into a company A, which is collecting data, it's a live data. There is like thousands of reads are happening on sub-second level. Okay, writes are happening there. It's a living, breathing data. So the thing is that in order to process that data, you really create a data warehouse where based on certain semantics or whatever your method is, you really you pull that data and you store in silos. So for example, in same organization, there is a finance data, there is a user data, there is a HR data. It could be everything in one big database, and all these EDW is doing is just creating a small data sets where the variety of users are really using that data. Everybody work is their own way, their own data, because same thing, if you think about the clickstream data, when your information is in 300 fields, if there are analysts, certain fields are useful for certain analyst and certain fields are useful for another analyst. It's a two views of same data, two maps of same data, and two results of same data. So what are the concerns with this existing approach? There are several we can talk about, and these concerns are designed based on future, based on fast access to the result. It's not like the system is not working. Last 20 years it worked fine. Even it's working for companies who doesn't want to invest in new technology. They're still working very good. The only thing is it just adds up a little more complexity, the way the new kind of data is coming. So first, the data prototyping is a significant investment. Okay, we already talked about that. The data storage and repetitive processing. Okay, data storage cost, because the thing is that when you are storing data in traditional databases versus you are storing data in HDFS, there is a really very big difference. Because if you are using traditional databases, it's about it's not industry standard. It's not, so don't quote me that, oh, I have said that number. But average, like the way we understood through financial analysts, that cost to store a 1 gig in HDFS is cost about 10 cents, versus to cost to store a 1 gig database in 1 gig in database costs about $1.10. So like 11 times cost. So think about that. If you are going to drop a 1 gig file in HDFS, you are just dumping a simple flat file, because cost is associated with the data processing. Because once you store data in table in RDBMS, you know what kind of structure is. Now your cost to process is very cheap now. Because you can hire some guy who understands SQL quickly, and he can write query for you, so you can take the $200 Microsoft Excel, and it's going to connect with your SQL tables, and it's going to give you nice visualization. You don't really need any big thing there. So you see, there are two ways to look into. But once you dump information in HDFS, you didn't think about that. It was very cheap to dump. That gives you another idea that why the concept of data lake is, that's data lake. Just keep dumping there, because cheap to dump. So for example, companies, credit card company, these companies, they actually collected your information last 10 years. They were storing in databases, but it was very costly. Now they move all that data to HDFS, because the cost of saving is really very cheap. They dump it and they will think, oh, we will find some way, we will find some guy, we will buy some third-party tool which is going to find out, hey, can you tell me what the intelligence here is? And now they are really finding ways to process, like the Netflix is a very good example. They have all that data, and now they are really churning that data out and coming up with some new, more algorithm. They are really sharing all that research outside. But this is because they had the data. If they really didn't think about what it's need, because there could be one person who say this is garbage, why we are even collecting it? It costs $1 to store one gig, we are wasting our money. So, but it's of later uses. Okay, and then here is that the real user, they never have access to full data, because they are working with middlemen, they are working with middle technologies. So they are working on a very small part of data. And finally, the knowledge gap. It's very different versus who really needs to have access to full data. So the thing is, and in most of the cases, IT is one who is really managing, IT and corporate strategy. So they really manage, they say, oh, this is what, you're going to get only this kind of data at this given time. You need to work it out. So the 20 years, the enterprises were created that way. And new person comes and he follows same way. But new age companies, new age enterprises, they really say, oh, this is not the way. It was working well, very good, but let's give a spin and let's try this way. Everybody has access to full data, because now you have ability. That's when new research, new things could come. Okay, so there is no one point who is really managing that data. So now the concept of data lake with the HDFS, it's the same thing. The users are still there. But the thing is that what is happening here, that data is actually stored in HDFS here. So there is no scheme. There is definitely some structure to it, but there is no defined schema. Because IT, HR, logs, everything is really dumped there. Okay, and if you think about HDFS, as I mentioned, it's a file system. Like the way you create your Windows file system, you create a file named abc.txt. You store in your disk, or if you are in Mac, you store your file in ext file system. HDFS is that same file system. So if I collect 1 million rows information about anybody, it becomes a file named x.txt, which has 1 billion rows. In HDFS, it's going to store it as a file in a folder called X or a folder called ABC. That's what HDFS does. You can store terabytes and petabytes of data in files. So the thing is that HDFS, while it stores the data, the map produces which process the data. But the thing is, not everybody is genius. Not everybody has tons of money in their pocket to hire these map produce guys who can really process everything for them. So ecosystem really adds up to it. And so for example, Hive, which is a part of ecosystem, and what it does, it sits top of Hadoop, and then when you look into HDFS, your file is a text file which has 100,000 or 100 million records in it. But when you look same file through Hive, now you see, oh, that's not a file, actually that's a table which has 100 million records of it, and there are so many fields to it. So Hive took that complexity and gave you a very different view. Pick does something differently. So there are so many pieces come. So what is happening when you have that way? So there is a data map. As I mentioned, that if you have a file which has a 300 columns in it or 300 CSV like comma separated values to it, you can create multiple maps and you can select which columns you are really looking for. Okay, you can remove the repetition when you are reading to it. So there are so many things you can do. So everybody has access to same data through a different data map. So here we come now to define what is like technically we call it a data lake, technical term. So the thing is that when you move from traditional data warehousing or databases to HDFS, first you are dumping all the information there, no modification. Every team members really have access to full data in their view, so they can really do independent thinking. The concept of intelligence is applied in processing right now. So lots of new business intelligence, like you see, so if you see that the investment is actually done a lot in Hadoop platform, you already saw like almost $1 billion invested in a few weeks of time in the platform itself. But there is lots of money is really being invested in the application front of time, because everybody is going to use Hadoop to store the data, and 10 times or 100 times the data processing or how the data is really, because everybody has a different need. Everybody really want to see something what others cannot see in their data. So these business analytics companies are coming. That's why you see there are hundreds of companies and there are billions of dollars really being invested to make Hadoop more useful. So these companies, they know the power of Hadoop, but power of Hadoop is in how it's really store the data, which is concept of data lake, where you have less governance, more visibility to the data. But what happens that thing really freaks out to the companies like the healthcare. So that's why you see that the security, data governance, that's a really, everybody think about it's a nightmare to deal with it. So there is an Apache project, it's called Project Rhino. And what Project Rhino is, that like help enterprises to build the security and data governance within this framework. So when you have the HDFS, because every team is really looking into different views, you really build the security in perimeter. Rather than if you look into the databases, so there is a security to access database. Only a few key person has access to main database. When that a small piece of data is out, now the analysts only have access to that data. They're like security in every layer, every channel. Everybody has a different kind of badge. Everybody has a different kinds of security to access. Here is a consolidated security. Not a lot is still using the infrastructure security. So now if we think about the security in this concept, it's a very easy to understand. Because HDFS is sitting on the native file system, you can use every security available on native file system. How many companies are using Linux in their enterprise? Almost everybody. How many companies are using Windows? Those who are not using Linux are using Windows, almost everybody. So it means that if you look into the enterprise, nobody has problem with using their problem, we can argue. But in terms of using, yeah, companies were running smoothly. Either using Windows or using Linux, and they had a file system. They had an ADFS, Active Directory server, or they had an LDAP. There was security, encryption. We can talk about hours and hours, but the overall idea here is that if you can secure your file system, you can secure one more layer top of it. So HDFS doesn't provide a native security, it rolls over. So if you have that security built into really very tight, you can control the perimeter. Who has access? Who has access to folder? Because it's a file-based access, it's a file system. You have a file and you have a folder. If you say this person cannot access that folder, that person cannot access that folder. Same thing as in a database. You are creating the table, you are creating the shards. You can say, oh, these shards are only accessible by these guys, and they will be accessible. Otherwise, you might get data permission or whatever error. So pretty much you can really do all those things there. And the two things are really very good. That at the bottom, the depending on depends, scaling up and scaling down is possible. That was always possible with traditional databases too. There was a complexity. The complexity is that you really have to, if you are adding more machines to SQL, how many person really added in this room more machines to their SQL? Yeah. It's not like easy. If I give you the comparison, what happens in HDFS, you want to add one more machine. You add one more machine, you put hard disk, you put whatever memory is really needed, you turn it on. Now you have that machine as IP address. Now you go to name node and you say, hey, you just go update and you just add one more IP address to that machine, and you really provide where in that disk where the files is going to be written. Once that machine is up, the service are running. Now that machine is part of system. So technically, if nothing goes wrong, you really have 5 to 10 minutes to really provision a new machine. Now you have 1 terabyte more available. So the easiness to add more machines up or down is really very easy in this concept. So when we talk about again concept of data lake, it's like you can pour as much as you want with very bare minimum interruption. And finally is the data redundancy to keeps guaranteed data availability. That's always there with SQL too. You can really access all that thing. And how here is that? So because we are talking about HDFS, so that question may be in your mind, that how HDFS really keeps your data secure or available all the time. So when you are copying data in HDFS, the data is cut into the blocks, tiny pieces of data, and those blocks are scattered on multiple machines. So when you are keep pushing the data to Hadoop, when the Hadoop system takes that data, cut into the pieces called blocks, and you as a Hadoop admin, you set that this is my block size. You can set up from 64 meg to all the way 1 gig each block. So now what's going to happen if you are pushing terabytes of data in the file? It's a 1 terabyte file or whatever is millions of files connected as a 1 terabyte. Actually, Hadoop is seeing those files in block based on your 64 meg or 256 meg, whatever your size is. So that's where the block unit is. And remember, we were talking about bring the processing to the data. So when you are really processing the data, the processing is actually done on a one block. So if you distribute those blocks on hundreds of machines, you can distribute the processing, and each processing is really taking small amount of time to process that data. So that's blocks, and these blocks are redundant, and the default redundancy is 3 blocks. So when a file is copied on HDFS, that blocks is replicated on 3 different blocks, 3 different machines. So if 2 machines are gone at any given time, you still have one machine which has the block available. Okay, so that's where it keeps the redundancy and availability high. And it also helps MapReduce to do work faster and work smarter. So for example, you are processing the data, and what is happening that one machine suddenly, due to some other process, is really sluggish on system resources. So jobs are running, tasks are running on multiple machines, and this machine is really doing slow. MapReduce, the job tracker, getting results from every machine, and it say, okay, all the results are available from this machine, but this machine results is still stuck. I don't know what is happening. What it will do, because it knows that there are 2 other copies of that data available on some other machines too, it's going to send a request to 2 other machines and say, can you process that data here too? Because replicated data is there. So this sluggish machine is doing very slow job, but these new machines, they took the request, processed the data, send result back. MapReduce job tracker say, okay, I got the result, I don't need, it's a kill it. So it's killed. So it's a smart processing is done. That was never done in traditional environment. So it's a lots of ingenuity and a lots of research and lots of really very amazing way to process the data. So like when you can actually keep the redundancy to 10 if you would want. It's just gonna take copy. So if you have that big redundancy, that's gonna take your storage, so you will store less data. Okay, and there is like compression and decompression. You can compress the data and Hadoop decompress data natively. So you have very fast way to store lots of data and process lots of data just by doing in-memory decompression. So those kinds of things you can understand from data lake here. So finally we can say that Hadoop is the answer in so many ways, and based on like my experience and the way I'm really trying to put together the whole thing in context, it gives you that if you really want to look into Hadoop, Hadoop definitely can solve these kinds of problems. Okay, so like for example, when we talk about Windows Azure, we really thought very seriously, collecting. So we had, so by the time in 2013, there was almost 300,000 machines per data center, and there were like 6 data centers. So at any given time, there was 1.8 million machines running. And in order to maintain all those machines and understanding what is going on, the thing was that we were almost collecting these data, and then our mean time to solution for a hardware failure was almost like about 45 minutes to 1 hour. In that time, the 30 minutes time was to get the problem bubble down to us. So a problem happens. So you think about data center. In data center, there are thousands of machines. And these machines are mainly called host. So there is a rack. Just think about in conceptually, there is a rack. Okay, there is a whole like fridge kind of machines. Okay, and there are so many machines are running, and each machine is a blade. Okay, each blade, just think about it, has a 8-core CPU in it, and it has a 60 gig RAM, and it has a 8 terabyte hard disk cumulative. Now you go cloud, you go Amazon, Rackspace, Software, Azure, or Google, Compute, everywhere you go, you say, give me a machine. What you are really requesting to the infrastructure, that I need a machine, then infrastructure will say, what kind do you want? You say, give me a machine with 2 core with 4 gig RAM. Okay, and then give me a terabyte. With each core comes 500 gig, so you got 1 terabyte. Okay, this is your machine. So you got, in that 8-core machine, you got a slice of 2 core resources available for you. Somebody comes, says 1 core. Somebody says, I need 4 core. So that's the way the distributions are, and machines are really running. If a unit, which we call it guest, is failed, guest will tell to host that something is problem. It is very much possible that guest never even say anything. It's just there are resources clogged in a way that is suddenly stopped responding to the host. Host didn't get heartbeat after a certain amount of time. Host thinks something is wrong. Host try to something called fix that problem. If it doesn't fix, it comes back, it tells to its parent, hey, I think I have one of my guests has a problem. Now that host, because there are that rack, one rack, every rack has a parent, which really takes care of everything in that rack. And then there is like tens of rack becomes a one cluster. And then one couple of cluster becomes a one unit. So now you see that by the time you take that problem slowly coming out, by the time you see it's already 15 to 20 minutes. But if somebody's business is running, somebody really had their blood and money is all going in that machine, and as a data center owner, you really let machine die. No work for 30 minutes, it's a big loss. So all that things, in order to prevent that thing, you collect all that data. So first of all, data collection is very fast. Understanding the problem and finding that how many times that self-healing went through, what was the reason that self-healing cannot come back and say, oh, I think this problem is maybe network failure, maybe hard disk is gone, maybe the memory has some ECC bad, which really, because if you are dealing with like 1.8 million machines, it's havoc, like there are 300 person ready for you to tell what's wrong where, what's wrong, go to fix it, but it's just guiding them to go, which place they need to open is really very, so using that, it was really, because once you put the data, the intelligence was in software, because when you are using traditional RDBMS, most of the work is done through SQL, it's all about SQL. As smart your SQL is, and smart your results are. But now we came out from that thing. We say, no, we're going to go and use traditional, really very high-end software methodologies like predictive analytics, recommendation. There are tons of things coming in existence now. Plus, we're gonna imply software on raw data. Once you have in that raw data, now you have full power. So companies like IT, companies like HR, companies like for example the infrastructure, they have full power, and that's what the advantage of having that thing. So I already talked about like HDFS a lot. So you have HDFS, and I'm talking again and again that when you have it, because if you are using Hadoop, you have HDFS and you have next thing is MapReduce. So you are using the power of these two to really create a solution which is very useful to you. So I think we still have time here. So now we can look into how the data processing happens in Hadoop. Okay. And how the MapReduce works. So I will spend some time to explain, how everything is really happening, how MapReduce, how that magic really happens under the hood, which really gives you answer. Okay. So we already talked about the unstructured data processing. Okay. If you are in Hadoop, you really dump your data in HDFS. Okay. Smartness is built into your MapReduce code. Some companies, they have ability to hire these guys who can do these jobs. Some companies license these softwares to do that job, and some companies try to invent a total different way. So like for example, Spark, like the incubator program from Berkeley, is really getting very good, I would say, recognition from industry, and lots of new companies are coming with that way. So we can look into how it's really processed here. So first of all, we store data in HDFS. Okay, so first thing comes, you know what kind of data you are storing. It could be a text, it could be a picture, it could be a PDF file, it could be a doc file, it could be a PNG, it could be anything, but you know what you are storing. So as being the IT administrator for your Hadoop cluster, you know what kind of data is. So at least that's a very first knowledge about it. Once you have that knowledge, you really can go next level, and now you can think, okay, if it's a PNG, how I really going to read that PNG? And if it's a PDF, how I'm going to read the PDF? Because the data is inside that content. So there could be a folder where you have collected almost millions of these documents, which could be anything, and now you're really trying to process it. So the processing, the way it will done, you cut your source and you understand your source. If it's a simple text, it could be simple text. If it is a text plus compressed, your processing would be, you need to really read that, you read the compressed data, uncompress it, and when it's uncompressed, then you really need to read into it. Okay, so those are the smartness is really built into your software. They're definitely using MapReduce as a complexity, but the complexity really gives you a variety of results. And results, the enrichment and results is what the beauty, what we are talking about Hadoop here. Okay. So now, when you understood how to uncompress the data, so there are several, if we look into the data storage ways in Hadoop, there are several new methods. Anybody heard about Parquet format, Parquet file format? It's a very popular these days. It has a very high level of compression and decompression. It can really do fast. And I would say the new companies are using Parquet a lot. Okay, ZZip was already there. So many companies already work. RC file, sequence file. These are files. Okay, and then Hadoop already provide like native, snappy compression. This really well is introduced by Google. Like in Google Data Center, is all about snappy. They use it. So when you use these really well-known algorithms, which really proven companies like Google, Microsoft, LinkedIn, Netflix, these are using Facebook, you really know that you really don't need to invent the wheel, just go and pick it up and just use it. They spend already billions to understand it, just use their results. Once you use their these algorithms, now you have ability to read through it, and now you have the map of data. Like if it was a text file, now you can peek into and say, oh, what kind of data is it? Next comes the data cleaning or data tidiness. As I mentioned that if it's a redundant data, you can apply a code to remove the redundant data and making it as a complete. So you can see that this line was used 100 million, 80 million times out of 100 million row. Now you really cut down your results. So you can use that. It's all done through code. Okay. Now once you have it, and when you are reading that data, you are actually seeing a one single view. While your data was distributed on hundreds of machines in blocks of 64 meg to 1 gig, whatever you really choose it. So the complexity to read the data is total hidden by the framework. So as if you are a programmer, you really don't need to go and learn all the pieces, nuts and bolts about distributed programming, because it's already been covered for you. Next happens that when you are, for example, you are processing the data, the processing is done through something called key value pair. So MapReduce process the data based on key value pair. And now everything comes back to, okay, what is it? So the origin of Hadoop really comes to understand that why we are using key value pair. So if we go very back, look into Wiki and other places, actually the MapReduce and HDFS were introduced by Google. It was a Google research who created this paper, and the Doug Cutting from Yahoo who took this paper and he really built this Hadoop. That's why it came in existence. It was not HDFS, it used to call GFS, it's called Google File System. So Google File System, what we call now in HDFS. So everything was designed for Google, and what Google bread and butter is, so their search business. They really search, they look everything, open it up, find it out what they really need to look into. So how MapReduce work, we just use the key value pair to process that data. Key value pair is like, you take now even if you had a terabyte size of data, you are looking into a single block which is either 64 meg or 1 gig, depending on what your block size is. So you are looking into very limited size of data now. You are just making each line row, and it depend on how the coder really understand, is really saying, okay, if this what I'm really looking for, if this is a very 300 column line, what value I'm really looking for in which key. So that's one way to look into. Now if I flip switch totally and I say, actually you can use Hadoop to process the data. So all that the Hubble telescope, everybody knows here, how many pictures that machine really generate almost on daily basis. It actually generates terabytes of pictures on daily basis. And all those pictures are stored, the downlink happens from a satellite or Hadoop, Hubble, and they're really stored in NASA servers. It's a public server. You go, you say, I really need to access the Hadoop images, and you have all the images available. You can use Hadoop to process those images. Now, what do you say that what is the key value pair? Because it is possible that one image could be about 3 terabytes. It's a full resolution image, and it's a composite. So it's a composite of 10 images slashed one each other from different wavelengths. So what you are really seeing is a very different what Hubble sees, because it's a fabricated image based on multiple, so we can really understand out of infrared range. So you can use Hadoop code to understand how you really want to use. So it's key value pair, but it also goes beyond that model to how you really want to process your data. So same thing, like what about reading PDF, reading doc, reading PowerPoints? You can read everything. That was limitation with your traditional RDBMS, because now you are storing the data, you don't even know what you're going to end up having it. Okay, so that again proves my concept, my point of having data lake, because you are not leaving any garbage out, because in enterprise there is nothing garbage, everything is very useful there. Okay, and finally, what happens when you are I think lots of folks in this room already have EDW kind of systems, all that things are running. So there is one thing, when you are doing EDW or you are doing processing through your database to all that thing, what you do? You have access to full data. Now you are moving that data, and then that data is available to somebody, which is a percent of that data, and that person is making results, and then he has a percent of that data. Now you have, like, you started from 100%, you gave 20%, now you have a 1% of 20%. That is your business insight. But where is that? If this person really wants to know where is that 1% insight, that insight is that person computer or that person account, because it's already moved. Data lake concept is nothing goes out. If processing happens, results are here, they still gonna be here, because in HDFS, when you process the results, process anything, the results stayed in HDFS. So that is available for next person to use. Versus in traditional, you move the data, by the time you move, now you need to have another method to bring that data back to your source. But that's really very small thing. So that's when you are using HDFS in that way. Because nothing is going out. Everything is available, and now it's a different map. Because if I created one insight and insight is available in the HDFS, another team can come, take that data, merge with another data, and you come up with another thing. So that's the beauty of using this whole thing. So technical information about HDFS is just for like review purposes here. So it really provides you that it's a fault tolerant self-healing. So fault tolerant, as I mentioned, that block replication, okay, and self-healing. Self-healing, I give little, but I can add little more to self-healing here. So you have machines. If you have hundreds of machines, which is your cluster, what happens if one machine goes down? In Hadoop, as I mentioned, there is in HDFS you have name node and you have data node. Name node has the audits of your files. Data nodes where actual blocks are stored. So name node has the information about which blocks is stored in which place, which file, if you have a file, how many blocks for that file, and how many blocks are distributed across how many machines. If one machine goes down, that machine is not available, all that machines are sending heartbeat on a periodic interval to name node that, hey, I'm alive, I can take care of your job. I'm alive, I can take care of that thing. If one machine is not sending heartbeat, now the master thinks, okay, something is wrong here. I don't have access to that machine. But no panic, because I still have 2 copies of the data, whatever was there in there. But now the thing is that you have 2 copies of data. What if other machine goes down? Machine will think, it's very smart system. If you go deep, you will understand, okay. So machine will think that, okay, I will need to get everything was in that machine replicated to 3 blocks again. So I have proper redundancy. So name node will find out that there are hundreds of machines on multiples of rack, because if you are using here, there are several rack. Hadoop has built-in rack awareness. So Hadoop will know that the closest block in that area is in that rack. So it will use the closest block to replicate in a machine where it can replicate. So it will think about that if I move a data from that block, which is about few milliseconds far in network latency, it will think whatever the closest block is available, I really need to bring back to make it 3. So everything is calculated on millisecond level, they are not even second. So it's a self-healing model where you can, new things is come up. If data is not available, then MapReduce, as I mentioned, that it can push job to other node, it can figure it out. If the one node is slow, even there is no problem, it will spun another job to another machine. Say, okay, let's do it. If this machine is behaving badly, name node has a concept of blacklist name node, a blacklist data node. So if a data node always having problem, like the jobs are given, they don't come on result on time because the hard disk has a slow read rate, because every hard disk was really very good, 10,000 RPM, but this hard disk is like maybe came out from your grandpa computer, which has a 3,000 RPM, but you thought, oh, let's put it here, and you put it there, you know, it's working slow, and then name node is gonna blacklist it, because of that node, everything is slowing down in the system. So name node say, I don't like this name node. So those kinds of self-healing is built into the infrastructure. And that's why you see that within like few years, the technology became really very prevalent. It's just going everywhere because everybody understands the power behind it. You got everything free. You just put your machine, you do it, and then we're gonna be learning about that, how you can take advantage of this thing beyond. If you don't have infrastructure, you just have some few dollars, you really want to go through and you want to try Hadoop, how you could do it. Then we can look into the model of cloud, where machines are already there, you just pay as you go. A few, like about the average Amazon is like 8 cents per hour per code, Azure, Amazon, Google Compute. So if you are building a 10 node cluster, it's a 2 node machine, so you have 2 node multiplied by 10,
as 10 nodes, 2 core, you have 20 cores. If you are paying 8 cents per hour per core, now you are paying $1.60 per hour. And if you are running that machine for a couple of months, now I'm talking about less than 1,000. So if you have a $500 in your pocket, you have a Hadoop cluster running. You are enjoying the benefits. Not only that, if you go Amazon and Azure, you just sign up Amazon account and they will give you 750 hours free with 2 cores. So if you are dealing with only 2 cores and you are not exceeding 750 hours, means 2 months on 2 core machine. And you can actually run a free Hadoop cluster just paying 0 cost. So if you just want to try it, if you don't even want to do all that thing, then you can use EMR. So we will be talking about creating a Hadoop strategy for your enterprise, and I will be looking into EMR, cloud, which one is a session from 3:30 to 4:30. And before that, we have 2 hour. Yes, please. Yeah. Yeah. And that's a very good question. That was a concern up to Hadoop 1, when there was a second concept of secondary name node, and secondary name node has a delayed latency. It was not as a high available. Highly available and secondaries are two very separate terms. You know, it's like a day and night difference if we think about. When you are using HDFS 2, Hadoop version 2, there is a concept of secondary name node. And secondary name node is synced with master name node with at 400 millisecond whatever network latency, because in two network pipe there is a 400 millisecond latency between the stack what you are really using it. So that was really synced. So if your master node goes down, the high available name node picks it up, and you have a concept of up to 3 high available name node. So if the 2 goes down, 3 goes down, you still can recover with it. It was a concern before, but now I think from December 2030, if you are using HDFS 2, and you can pick and choose, you can have HDFS 2 and MapReduce 1. The only thing, if you have HDFS 1, then secondary name node is still available, depend on which version you really choose. Being open source is like a little bit hodgepodge there. But if you are using Cloudera or HDP, Hortonworks, they really give you a solution which really bind together. So secondary name node really takes care. So, yes, please. So the way it is, if you are building the cluster, you add the rack awareness. So you really know that rack, because rack is a conceptual term. You really group certain machines and say these are the machines in one rack. It could be a physical rack where you have 8 or 16 blades are there. So if your cluster is like 20 racks, and each rack has 16, so you have 16 to the 322 blades now. Now you say that I have really physically there are 20 racks. Now, but you don't have that, you have a single rack and then you have 16 machines. You can conceptually say that each machine is actually rack. And now you have 16 racks, so when the HDFS is going to do copy, it will copy in different racks. So if the whole rack is going down, it could be a whole rack, because how many network ports are available. It's like you can really define in a way. So HDFS try as best as can, because it also depends on how fast you build your cluster.
So what does this happen that data turn out to be residing in the same stack and
It's depend on how data is really distributed again, because if there is no rack awareness, that there is no, because Hadoop doesn't really know, it doesn't even know that what kind of architecture you have, it just knows that you have an n node cluster. and it will use its own intelligence to distribute that data. Once you start adding rack awareness, now you really know that if I have 3 racks, I really need to have 3 copies in each rack. Because when one rack goes down, I still have 2. If you have multiple racks, then it is really try to still use 3 racks, 3 random racks to put the data. So total number of blocks divided by total number of racks, and then the blocks will come, then it will be distributed. There is a chance if you have a 3-node cluster and if you have a 3 replication factor and all 3 is gone, then definitely you are host. So that's where that you really can do anything at that point. So there is a fault tolerance, redundancy built into, but it's all a lot depend on how smart you build the cluster. You can build a cluster where you can reduce the percent. It goes 100% failover, because if you have a 3-node cluster, 3 redundancy, all 3 gone, 100% failure. Now you have a 3 with 4-node cluster, you added 25%. So you just keep using math, and it really talks about how you can really go it. So finally, I will conclude this outlook. So data lakes is for reduced engineering overhead, faster access of your data to the real users. Data is really being staying in HDFS, so you can keep reusing it, and repetitive processing. Because if one person already has done that thing, and everybody is dealing with the same data, then why somebody has to do? Which was very far, is a foreign object for a traditional database, so you can take from that. So I will see you guys back in 2 p.m. and then we have next 2 hours. Go ahead, enjoy the lunch, and if you have any question, feel free to ask us, and then I will see you guys. Thank you.